Alright, here's the wood I'm going to be using. I'm going to be working on the floor today. So I've got some 4x4s pressure treated, some 2x6s pressure treated. And I think that's all I'll need for today. And there's some plywood there that I'll be using. And I think these are the tools I'll need. So I've got a miter saw and a power drill and some squares, framing square and a speed square and a 3-foot level and some miscellaneous things, but I think that's all I'll need. So time to get to it. Alright, so I've got my beams laid out where I think I want them. So I've got them going down that way. So 1 beam per 3 piers. And I laid it out this way just because there's more room to drill the holes this way than if I were to go that way with the beams. And so you see, so to try to get them squared up, I set up this line that goes from this bolt down to that one, and I'm measuring an equal distance from the string to the end of this post, so that they'll all be relatively at the same position on this side, on the right side, so that on the left side they'll all be at about the same position there too. So, okay, so I have leveled the 4x4s out, and that's what we have. So that took a little while, but it's worth it. Don't want an unlevel shed, and so I think these things are going to be a problem now. Probably gonna have to cut those and then make little notches in the 2x6s that's gonna sit on top of here. But oh well, I think it'll be okay. Level. Look at that. Anyway, so I'm gonna start putting the 2x6s up there to make the floor. Alright, so I've got all my wood cut for the floor, or the subfloor. These are all 2x6x12s. So these pieces that piece that's facing me right now is 12 feet long. And in order to make a 12x12 box, those cross members need to be 11 feet 9 inches. I also got it squared up, which is very important for your floor. Because if you don't have a square floor, then none of your measurements are going to work out very well. And everybody on YouTube says, make sure your diagonals are the same distance. And what they really mean is use the Pythagorean theorem. So you take this big box and you make 2 triangles out of it. You just draw an imaginary line from there to there. And since it's a 12x12 box, you do 12 squared plus 12 squared equals some unknown number squared. So you take 144 squared plus 144 squared, and you take the square root of that, and you get the diagonal measurement that you're supposed to have. And for this one, it turns out to be 203 inches and about 3/4 of an inch. And I got roughly that, so I'm happy. So now I'm gonna, these are connected here, got those screwed in, and I've got this tacked in place. Well, not tacked, we're not welding, but it's held in place by some screws to the 4x4s. So now I'm going to be using these handy little things that I drew. Those are my 16-inch on center markings. So I'm just going to center up this board with that mark and screw it in. So do that with all these boards, then I should have a subfloor. I think that's about it for now, so I'm just going to go screw those in, then I'll start putting plywood on top. Now I've got the floor all braced, so I had the joist running lengthwise that way, but if you just kind of leave it like that, and these are 16 inches on center, so with this 3/4 inch plywood that I'm using, I've been told it will be a little squishy. So to add extra support for the plywood, I put those braces in, and so those are every 3 feet. So there's 4 boxes go running down the length. And remember, when you cut these, this one is going to be 3/4 of an inch shorter than all of these middle ones. Pro tip. anyways, I screwed all those in. So now I'm going to put the plywood on. And something I didn't mention was these joist hangers that I hadn't put in before, but I was told was a very good idea. So install joist hangers to hang your joists, floor joists, ceiling joists, whatever. And notice that these are staggered so that you can screw the blocks in on each side. So now I'm going to put this plywood on. I have 5 sheets to cover this 12 by 12 shed, and I'll have half of a sheet left over, so a 4 by 4 piece of plywood left, if my calculations are correct. And after I've got everything, before I put down the first piece of plywood, I'm going to make sure that the floor is square. And when it's square, I'm going to, right now the floor is not, it's just tacked down with that screw there and one on that other corner. So I'm going to square up the frame of the floor with the first piece of plywood. Then I'll just start screwing it all down and everything should just work. Here's the decking all on, and it's level all directions pretty much, so that's a good thing. What I did, there are 2 layers here. So I put the 3/4 inch that I had on there, and not sure if you can see that, that's on the bottom. And then I got another 1/2 inch treated plywood layer on the top. And the reason for that was the 3/4 inch wasn't as firm as I would have liked, but that's all taken care of now. And I don't know if you can see the pattern, maybe you can, but I've got, let's see, 1, 2, 3 full sheets of plywood there, a 4th one here, and then half in the corner. And the layer on the bottom has the same pattern but in reverse, and that's to minimize seam overlapping from the 2 layers. You don't want that. So that corner piece on the bottom layer is over in that corner, so remember to do that. And when I put the second layer on, I use some adhesive that I got at the Restore, Habitat for Humanity. You can see that coming out there. There it is. Anyways, that's very important. Bond the 2 layers together. And when you're screwing the second layer down, you only need to screw into the first layer. So you don't need super long screws to reach into the floor joists. That'd be a little tough. I guess the next step is to start framing stuff.
Welcome back to Bridgeview. Today we're going to talk about how impacts to the river are minimized during construction. We're going to be on the construction site today, and we're going to be chatting with Zach Riley, a superintendent with Kiewit Infrastructure West, our design build contractor for the Portland-Milwaukee Light Rail Bridge. So let's get on our safety gear and go. So Zach, I understand that in-water work can only happen during a certain period of the year. Why is that?
Well, in-water work can only occur between July 1st and October 31st, and that's basically to limit the impact to the migratory salmon. During that period of time, the least number of migratory salmon are present in the Willamette River.
So what type of work do you and your team do during the in-water work window?
During the in-water work period, we focus on the installation of the piles for the temporary work bridge like we're standing on right now. We also focus on getting the sheet pile in for the cofferdams. And then the last part of it is the scour protection around the exterior of the cofferdams.
What are cofferdams and why are they needed?
Well, cofferdams are essentially an island within the river. So once the cofferdam is completed and the fish in the water are removed from within the cofferdam, we have a work zone that is isolated from the remainder of the flowing Willamette River. That work zone allows us to work within that area during all seasons of the river and minimize the impacts to the fish and the public that also use the river.
So the location of the cofferdams are where the location of the towers will be in the future, right?
Yeah, that's correct. As we said, once the water and the fish are removed, we'll backfill the cofferdam and give ourselves a platform on which to pour the footings for the towers, the large footings, and then out of those footings, the concrete footings will come the towers. So we'll build the towers up, and that'll be the primary support for the permanent bridge.
So in the in-water work window, you pile drive for the work trestles, you build the cofferdams, and you also place scour protection. Can you explain scour protection a little more?
Well, scour protection in this case is primarily a large rock, and there's 2 to 5 feet of it that we place around the cofferdams. The purpose of the scour protection is to prevent the river currents from undermining or eroding the sediments around the cofferdam. It's kind of equivalent if you've ever stepped in the ocean with a receding wave and you had your foot on the ground and that current tries to pull the sand out from underneath you. The scour protection would be like some small pebbles around your foot that would isolate that and keep that sand from eroding out from underneath you.
A lot of interesting information about the in-water work window and the beginning of construction of the Portland-Milwaukee Light Rail Bridge. More to come on the next episode of Bridge View.